run all. This will run all the cells, including this one, which will get us the new model with the new nonlinear kernel. Where is it? Right here. Kernel equals RBF. And so now it's very interesting because this time we have a nonlinear classifier. And therefore, I look forward to showing you the visualization results at the end, both for the training set and the test set, because you will see that we will get a super beautiful curve that will catch the right observation points, the right red customers in the right red region and the right green customers in the right green prediction region. Not all of them, of course, but the ones which couldn't get caught properly by the previous, linear model, such as the support vector machine or the logistic regression model, right? Remember this straight line? This straight line could not catch these customers properly in the right green region and these ones as well. And so you will see that now we will get much better results. But first, because, right now, I think it should be, loading, running the code. Yes. So we don't have yet the final result, but that's okay. Let's observe, the different predictions. So first, our kernel SVM was perfectly able to predict the right result here. Remember, with that customer of age 30 and estimated salary $87,000, who in reality didn't buy indeed any SUV. And here we get the same prediction. So that's all good. Then let's look at the test set results. All right. So let's scroll back up a bit. So that's the test set results. And well, once again, we have many correct predictions. An incorrect one here. The real result is 0, meaning that in reality, this particular customer didn't buy the SUV, but our model predicted that this customer bought the SUV. Then we have the same incorrect prediction here. Then all correct, all correct. It looks very good. Here we have an incorrect prediction, the inverse one. In reality, the customer bought the SUV, but our model predicted that the customer didn't buy the SUV. Then all correct, all correct, all correct. It looks very, very, very good, right? I really wonder if we can beat this accuracy. And that's what we're about to find out right now with, the confusion matrix. Are you ready? Are we going to beat the so far best accuracy we got, which was, I remind, 93% from the K nearest neighbor model? Here it is, 93%. And now let's see if we manage to beat it. All right, let's scroll down and the accuracy is 93% again. Okay, so we didn't beat it, but we reached the same level as the KNN. And now let's see if we get the curve. No, still not. All right, it's still running. That's because we have a small step here, 0.25. If you want this to run faster, you can actually increase the step to 0.5 or even 1, but you'll get a less smooth curve, a less nice curve. But that's okay. So, just in case it will get us the results in a few minutes, a too long time, well, let's maybe have a look at them in the original implementation, which is right here, okay? Just let's do that. Let's observe the final results, and here they are. As you can see, we get a super nice prediction boundary curve that catches this time perfectly well those green customers who couldn't get caught properly by the linear classifiers, with the straight line. This time it is catching them perfectly well, except these ones, of course, because they're trapped in the middle of many red customers. But these ones, which couldn't be caught properly by the logistic regression model or, the SVM classifier, right? If we have a look at it again, remember that the customers here couldn't get caught properly because of that straight line. But now that we have a curve, oh, there we go, we have the results. Now that we have this curve, well, these same customers, these are exactly the same one. These same customers are now caught properly in the green region. And same for these ones actually, these ones are cut in the right green region by very short. And same for these ones. And here, these ones are incorrect predictions. But once again, that's totally fine. We want to avoid overfitting anyway, because indeed, what's mostly important are the results of the test set, which we still don't have. It is still running, but we should get them in a second. Or, let's just have a look at them right here. So now the challenge is to see whether we have the same results on new observations, meaning on observations with which our model wasn't trained. And that's exactly the observations of the test set, the 100 customers of the test set. And well, wow, here now it looks even better, which makes sense, right? Because we had 93% accuracy. And since there are 100 customers in the test set, we actually have 93 correct predictions and 7 incorrect predictions. And we can actually count them here, the 7 incorrect predictions. You have the 2 first ones here, the red customers falling in the wrong green prediction region. Then these 2 here, 2 other red customers falling in the wrong green prediction regions, and then these 3 green customers falling in the wrong red prediction region. But that's totally fine. Once again, thanks to this beautiful curve here, we managed to catch these customers in the right region, which couldn't be the case previously because of the straight line resulting from the linear classifier. But this time, there we go, we have a nonlinear classifier, which is the reason why we have this curve, and that's why we get a better accuracy. All right, so I'm at the same time very happy and excited because this curve is beautiful and we got great results, but I'm still hoping that with a future classification model, like the 3 ones we have left, we can beat that 93% accuracy, which we got so far as the best ones by 2 models, the k-nearest neighbors and the Kernel SVM. So I look forward to seeing you in this next practical activity, and until then, enjoy machine learning.